Okay, moving on. We'll keep going. The next one, geez, the light's so bad here. The next one we're looking at here, guys, is the question 4, the furnace question again. One you should be going for, because it's quite easy to predict and it's easy to do. Just the same stuff sort of comes up over and over again. So they're asking you what's the type of the furnace, what's the materials in the charge, what's part A, what comes out of B, and what comes out of C. Okay, so that is the irregularity on that blast furnace comes up maybe, I'd say probably about 90% of the time. Okay, so that's why we really need to get to know it and just to know it well. Okay, so what we have here is, let me just fix this light a wee bit, it's just not great now. Yeah, a bit better now. Okay, so my sheet of paper, where is that here? Okay, so this is question 4. So A is the blast furnace. How I know it's the blast furnace is it's rather tall. It's probably the most complicated of the three of them. It's a rather tall furnace. Okay, so again, the blast furnace again. Usually they ask you how is it charged. Again, you need to draw the charging bells. So again, the blast furnace there. That's how we know usually the charging bells, and then you have 2 ports down the bottom, and this sort of like a belt pipe down the bottom. It's a Toye pipe, the heater. Okay. So name that. So the blast furnace, the materials in the charge. What is in the charge? So the charge is sort of what goes into it, what fuels it. What you have in there is coke. You have lime, and then you have iron ore. Again, those example. Anyone that wants going for an A, you'll be able to talk with. So again, coke is like it's a coal dust, and this burns to create heat. Your lime, it sticks to any dirt, so removes dirt. And then your iron ore is where your iron comes from, so it's a mixture of like rock and iron. Okay, and the iron comes from. So that's why. So again, that's your charge for the blast furnace. Again, it differs. Your electric arc furnace, again, all three of them have lime. So your basic oxygen furnace, your charge is scrap metal, lime, and molten iron. For the electric arc is a bit of iron ore, scrap metal, lime. And at times it varies. Could be molten iron. Okay. What is now part A? So again, I said coke is used to heat it. Another thing is that's used to heat it is a thing called a Toye pipe. Okay, I'll show you how to spell it now. What a Toye pipe is. It's Tuyee or Epipe. Pipe. Okay, and what that does is you have your furnace. So this is the furnace here. Great drawing of a furnace. Okay, and what you have here is there'll be on the outside of it you have like stoves. Again, these are burning huge to create a great amount of heat. This heat is pumped around the furnace, creating heat. So again, you have this is like a stove, like it burns. Essentially, like obviously it's huge, but it pumps hot air. That's the main thing with a Toye pipe is you get your hot air from there. So the two ways of heating it are you have your Toye pipe and you have coke. So the coke burns up inside, the Toye pipe goes around it to make sure that it's nice and heated around the outside. The next thing is asking us down here. It's saying you have name the materials taken out of furnace B and C. So again, you can see B is one height, C is the other height. If you're able to say slag and pig iron, again you get full marks. But if you're able to, but again you want to be able to talk about it in more detail, so a small bit more. So again, I'll draw that again. I'll just draw the bottom of this. So the bottom of the furnace looks something like this. We'll say. Comes down over, and again, oh jeez, don't tell me I haven't done that good. I'll do a bit crooked. Okay, so that's the two things you have. Okay, so one of these two, you have a tap that's a bit higher than the other. Okay, so this one here is for taking off. This is molten pig iron or molten iron. Again, iron is a ridiculously heavy metal. Okay, it's a very, very heavy metal. It's compared to the likes of aluminium and any of those alloys. And again, so it's gonna obviously sink to the bottom. It's heavier. Okay. Whereas your other thing, this would be what you call your slag. That's a mixture of lime and dirt and grease or whatever you want to call it. Impurities in the main word. That floats to the top. Okay, again, if you want to have an idea of what slag is, do you ever see it sort of be the same density or same weight as the likes of fertilizer? Again, slag is actually put out on land a lot of the time. It's because it's full of lime. Instead of putting lime on the land, you put slag on the land because it's cheaper. And the thing is, it has sometimes a lot of the stuff that comes, there'll be a lot of minerals and stuff out of the stone where the iron has come from. So again, that's why it's actually quite good for the land, is slag. Okay, so again, same density of about fertilizer, sort of dusty, and then molten iron again. Think of which is heavier. Again, molten iron straight away it's gonna be way heavier. Okay. So that's part A. So again, that was worth 10 marks. So again, the next one is to find any two of the following. I'm gonna go through all 4. So you have, oh Jesus, take that over there. So the first one is malleability. Malleability is a material's ability to be bent in shape without breaking. So it can be forced into shape, it can be shaped without breaking. Again, the likes of aluminium is a very my God, waking up. Aluminium. Okay, so again, the thing about aluminium, you can bend away, it's not going to break. You can bend it again. If you bend it more than twice or 3 times, it's going to break. Malleability. Something that is not malleable is the likes of brass. That is just going to break. That's no way malleable. Steel, wee bit. Glass, again, obviously, you're not going to be able to shape them. The next thing you're looking at again is hardness. Hardness is a material's ability to withstand being indented or scratched. Okay, so again, it stops from being indented or scratched. Again, it's quite it can resist wear. So the likes of thing, a hard material. Again, you think about it. You try and scratch the likes of glass. Glass is a hard material. Even the acrylic is quite hard. Brass, if you try and dot punch brass, that's quite a hard material compared to the likes of aluminium, copper, tin. All these ones are very, very they're not hard. They're in no way hard at all. Okay. Nope. Next one, conductivity. Conductivity. Conducts electricity and heat. That's important. So these conduct electricity and heat. Okay, so again, it allows electricity to flow through it. Allows these to flow through it. On a molecular scale, what happens is it bounces from one atom to the other, but you don't need to know that. You don't need to go that in depth with it. Okay, so your copper is the most conductive metal out there. Aluminium, very conductive. Again, that's why copper is used for the tanks at home in the hot press. Aluminium is all the power lines are aluminium. Okay, again, copper isn't used because number one for lines. Number one is it's incredibly expensive. Number two, it's quite weak. It'll stretch over time. The last one is strength. It's been able to withstand different forces. So again, something that is, again, if it's under torsion, so it's being pulled, it's being pushed, it's being twisted, it's being trying to be cut, all this stuff. Again, a strong material is able to withstand all those and be able to stand up through it. Okay, so again, that's what strength is. There's other ones there. I'm just gonna put on the 1 second. I'm just gonna put on the monitor for myself 1 sec now. If we go back to this, I have the list. There's a load of these here now, guys. Go through them if I can find them. It's a bit weak. There we go. There's other thing. Hardness, ductility. So ductility is it can be stretched into a wire. without breaking again. At the likes of brass, you try and stretch it into a wire, that's breaking. The copper is very, very ductile. Malleability, so it can be shaped or hammered without breaking. Allows electricity to go through it. Brittleness is something that it's again, it's opposite of toughness. It can be easily broken by impact. Again, brittle material cannot be bent. Simple as. So again, brass is quite brittle. If you try and depending on if you haven't heat treated brass, it'll break straight away. Elasticity, it returns to its original shape. Can withstand forces, and toughness can withstand sudden impact. Okay. So again, those are your different things there. So the next thing, I'm going to move on. I'm going to go back to my thing here. So there is your, I'm going to go back to my sheet there now. So you're looking back, last question. So again, that one was worth 4 marks. So again, 2 marks for each of them because it was defined any 2. And bottom, 6 marks. List the elements used to make each of the following alloys and identify the alloy used to manufacture each of the objects. So you have a statue and you have cutlery. Okay. So let me just go back. Oh jeez, okay, I've got this going again. And I need to go back to this. Okay. So, come on. There we go. So you have so bronze is copper and tin, brass is copper and zinc, solder is tin and lead, steel is iron and carbon. That was one of the ones that came up. What was the other one? The other one was brass. So brass is a mixture of copper and zinc. Okay, but just saying copper and zinc, iron and carbon. That makes steel. Stainless steel is iron and chromium. So chromium is what's actually, if you ever see the shiny bull bars of a Jeep, that's what they're made of, chromium. Or to be coated in chromium. Chromium is a very weak material there. It would probably be steel coated in chromium. They don't usually tend to be stainless steel because stainless steel is incredibly heavy compared to other metals. Okay, and I'm just going to get rid of this for a second. And then so again, you look at the other one. Again, it's asking us, so a statue, what could you make a statue out of? Statues are usually made out of bronze, again, because it looks a bit like it's like a mixture between copper and brass. Looks wise, it'd be cheaper than copper, but looks like copper, so that's why it would be used. And then cutlery is always stainless steel. Same goes for surgical equipment. What else would be stainless steel? Sometimes different artifacts and things like that, because again, it can be very shiny. Okay, so that's question 4. Let me just have a look at the other. There's your electric arc furnace. So again, charges lime, scrap metal, and a tiny iron ore. So again, these electrodes heated up, electricity goes through them, heats it up, and it's literally emptied like a kettle. Okay, so you tip this up, and it pours out the molten iron. You tip it back the other way, and the slag falls out the back. Okay, and then you have your basic oxygen furnace. The basic oxygen, so your charge is molten iron and scrap iron and lime. So again, there is actually no power in this. It's the molten iron that causes the heat. So it's quick. What happens is all you do is get it in, get it melted in the scrap iron, get it back out. Otherwise, get in the thing. So then you have the charge placed. So the hood is placed over. So again, this removes the hood and oxygen blown in. Oxygen promotes combustion, so it promotes a flame essentially. And once you pump oxygen into it, it gets molten iron going again. It gets it all heated up again. And then those are the steps there. Again, you need to know those steps and how it's emptied. Okay, so tap out is that, and then the slag comes at the top. Okay, again, you can see there your iron sinking to the bottom. Okay, same goes the thing there. And if it's slightly tilted, the iron is gonna slag might go first, but mostly molten iron, and then when it's finished is slag will start coming out, so they can just tip it back the other way. And that's question 4. So again, guys, don't be afraid to look over that one and the properties always tend to come up there. So either your furnaces and your properties there. Again, I have done 3 different things. Metals, more material again to talk about. So again, you need to look over them because the last 2, here's an application where it's used, and you have more up here. Okay, so advanced. So keep an eye on those. Okay, and that's it, guys. Okay, so I'm not holding you up for much longer. That's it. So I'll go through the other questions in tomorrow.